So class, today we are going to study other thermodynamic process, and that is on the basis of steps in which it occurs. See, we have done the types of thermodynamic process on the basis of what was the constant, isn't it? The constant factor. On that we have done the isothermal, isobaric, isochoric and adiabatic. Got it? So here what we are going to study, we are going to study about the on the basis of steps in which it occurs. So first is, let me explain, this is cyclic process. Cyclic process, as the name suggests, that means from where we start we reaches finally to this point, isn't it? So when a system undergoes a series of change and finally returns to its initial state, that means change in energy will be zero. Got it? Change in energy will be zero. No energy exchange over here. So A se chale and A converted to B, B converted to C, C converted to D, and lastly D again converted to A. So we got it back. Okay. So that type of process is called cyclic process. One more thing I want to explain over here, that work done in this cyclic process won't be zero. Now you can ask that if the energy is going to be same, so why not work done? So this part I will explain it further. Okay. So till now, just you should know this thing, that there will be no energy exchange, but the work done will be always zero. Clear? And this is equal to area of PV, area under PV graph. Area under PV graph. All this thing I will explain you later on. Don't worry about that. Okay. Area under PV graph. Now this is the reversible process. Reversible process which can be reversed, isn't it? So reversed equations of the first thing, if all the changes, there should be small changes. The change should not be big. Okay, let me write over here. Shouldn't be big. Be big. There should be small changes, and due to which at each step, each change, we will have equilibrium. Okay. We will have equilibrium, there will be chance to reverse it back. So if all the changes during a process can be exactly reversed, then the process is known as reversible process. That means the cyclic process can be reversed. See, cyclic, it means initially starting from A and getting back A. That is cyclic. But during this, what we have done, we changes to A to B, and that B itself changes to A. But in this case, what is happening? A changes to B, but from where we are getting A back from D. It's not a reversible. This is not reversible. Got it? If A changing to B and B changing to A, then only it will be reversible. Similarly, B changes to C and C changes to B, then it is reversible. But in this cyclic, we can see that A changes to B, but B is not changing back to A, or rather it is changing in C. Are you getting it? So this is cyclic process. Okay, and this one is the reversible process. So reversible process, we have to how we can achieve this and all, so that we will do in isothermal as well as in adiabatic process, we will do later on. Okay, so now and one more thing, this process is little slow, it is slow. Okay, this process is it will be slow, and as I told you, at each step there will be equilibrium. At each step there will be equilibrium. Got it? So this is the thing for the reversible. Now irreversible. Irreversible process, that means during the process, if the system doesn't achieve equilibrium, it is not going to be achieved, and that will be big. The change will be big. Okay, change will be big, and they won't be in the equilibrium, and that's why the driven force for the reactant to change it into product is greater than that of opposing force. That means whatever the force is required, whatever the driven force or driven we can say factor is required to convert A into B, is not equal to that driven force or driven things required for change of B to A. So that is called irreversible process. Okay, it will occur in a small big, and this will be fast. All this reaction will be fast. They won't be equilibrium. They won't be in the equilibrium. So that is for the irreversible process. Got it? So this is about the processes on the basis of steps in which it occurs. Now we are going to do work done in different thermodynamic process. So let's do one by one. The first thing is isobaric expansion. In this isobaric expansion, the pressure will be constant. Got it? And this formula we will apply. Where the constant pressure, or not in isobaric, just keep in mind, wherever this is, the pressure is extra, like there is a constant pressure, we can use this formula. There is no problem at all. Okay, so constant pressure, and actually the way to write the work done when the pressure is constant is not like this. It should be like this. This is the correct way, because we know that there is a small work done. We are doing the infinitely, like a small step. So in each and every step there will be small work done. So what we will do, we will collect all this and we will together, like we will add this, so it will give you the integration. Got it? So this is the correct representation for the work done. Okay, now so let it be like, if it is isobaric, you can write P external delta V, will be no problem. But if it is isochoric, that means delta V is 0, isn't it? So W will be this and it will be 0. There is no problem. The important thing where it will be asked, that is isothermal expansion. And this, in this isothermal expansion, we have to do two types of expansion, that is first reversible and another irreversible we will do. Got it? So in isothermal expansion, what it will be? It will be the constant pressure. The pressure is not going to change. Yes? In that, the first thing we have to do, this is reversible isothermal expansion. And the formula is the formula for the isothermal. Whenever you see this isothermal expansion, use this formula. Got it? So this is W is equal to minus nRT ln. This is natural logarithm V final minus V initial. And since natural logarithm we cannot find the value, so this can also be written as log to the base E. Okay, dear? So we cannot find the value in this. So it is 2.303 log to the base 10. So to avoid the confusion, I will always use, whenever we are using this log to the base E, I will use this ln. And if log to the base 10 I'm using, so I will simply write log. Okay, so this is V final minus V initial. It will be like, sorry, I should not write over here. So this W will be what? nRT log and 2.303 okay, log, and then V final minus V initial. How it comes, I will explain. Don't worry about this. Let me write this. 2.303 nRT log V final minus V initial. So this is the work done in isothermal expansion, reversible isothermal expansion. Irreversible, if it is so simple, this formula you have to use. Irreversible के लिए कोई भी हो, whether it is adiabatic, whether it is isothermal, whatever, we have to use this. Irreversible के लिए we can, because there the P external will be, we will assume as a constant. Okay, so got it? Now how it comes. So let's do the derivation. This is the derivation for work done in reversible isothermal expansion. So let's start with this. See, we have formula, this P is equal to minus P, W is equal to minus P external dV. And what we will do, since we will assume it as that the work done is reversible we are using, so that means it is occurring in the small steps. So for getting the all work done in the whole change, what we have to do, we have to integrate all these small changes. We have to integrate all this small work done. So that is, for this we will use this integration sign, and the limit for we will use that V initial upon and V final. Got it here? So now what to do? So see, how we will get this, that also I will explain, but let's start with the derivation first. Now we know that isothermal process, we follow the Boyle's law, and that is the, we get the graph like this, isn't it? So this is PV versus, and this is Boyle's law. So if we do this, what we get in this case, we can write that, and for the suppose that this is ideal gas, so we are assuming that PV is equal to nRT, isn't it? So PV is equal to nRT. Now this P जो होता है वो it is for gas. This is for gas. P is for gas. Got it? But here we are writing P external. So see, try to understand the things concept. Like in that thermodynamics, I told you wherever we are talking about the system is like this. The gas on which there is a piston kept over there. Yes. Done. And this is the gas, and here is a P external, and this is the wall. Should be, since it is isothermal, so it should be conducting. The wall should be conducting. Got it? Wall should be conducting. Okay. Now, so suppose that the system is in equilibrium. It is in equilibrium. To make it equilibrium, what we can do, we can keep small weight over here so that it will remain constant. Like the pressure is not going, neither there will be contraction nor the, because it is frictionless, so obviously the piston will move, isn't it? But so to keep it at a place, we are putting the small object over there, small mass over there. This is very small, very small. Okay, even can't be seen, but to make it clear, I made it like this. So suppose that right now, if I'm talking about the external, that the equilibrium, so what we have to see, this is the P external and this is the P gas. Yes. So at equilibrium, we can say that P external is equal to P gas. Any problem in this? Now, since we have to do that expansion, so that means the volume must expand. When it will expand? When the P gas will be greater than the P external. Isn't it? Got it? So, कैसे होगा? So what we will do, if we will remove this like small mass is removed, if it is removed, so what will happen? Less than, suppose that it is going to decrease by dp. Yes. So now P gas is greater than P external. Yes, because एक मास हमने निकाल दिया, छोटा सा मास, सो उसका हम समझ लेते हैं कि dp प्रेशर है. सो वी कैन राइट over here that P external, P gas अगर होगा, so what we have done, we have subtracted the dp pressure. So P external, we can write minus dp. Can we say yes? P gas हमने छोटा सा मास निकाल दिया जिसका प्रेशर इतना, तो इतना घट गया, P pressure is that much greater. Yes, done. So now, if dp is very small, very small, so can we neglify it? And if we neglify, what we get? We get that P gas is equal to P external, isn't it? Got it? So here we can write this, we can use this as a P gas also, because we are taking the reversible expansion and very small pressure is going to be removed, is going to be changed during the processes. So that's why we can use this formula, P gas. Okay. So now instead of, so we can write that P external also we can write is equal to nRT. So here P external, can I write nRT upon V, isn't it? Now use this P external in this equation. So we will get that minus nRT upon V dV, and this is V final minus V initial upon V initial, isn't it? And might be you have done in maths integration, constant will come out. So this constant N is number of moles, that is again constant. R is universal gas constant, and T is also constant because it is isothermal we are using. So here T also will come out. So what left? This is dV upon V, and the lower limit is Vi. Okay. So in that integration you have done that the small change upon the equal value, whatever the value we say. So what it is? It comes as ln V, natural logarithm V. Okay. So instead of this we can write natural logarithm V, and this is V final minus V initial. Okay. So if we'll expand it, it will give you nRT and ln v की जगह पे one time v की जगह पे v final, another time this. So we can write v final and minus ln v initial. Okay, now the log value, this is log m minus log n. What is this log? I will explain, don't worry about that. I will share the video for this to know the log and how to find the log values and all that. Okay, so there is a formula. This is log, suppose kar lo, this is m and this is n, so we can write minus nRT log m upon n. Okay, and as I told you, we cannot calculate the things, we cannot find the value in natural logarithm form. So what we have to do, we have to convert this into log to the base 10. So here we can get this work done is equal to ln की जगह पे we will put minus 2.303 nRT log v final upon v initial. This is the formula. This is the like to know the things. So I have explained. Okay, so this is the formula for work done in reversible isothermal expansion. Be very careful. If it is this reversible isothermal expansion, you are supposed to use this formula. If you will use this formula and that PDV, it will be considered as wrong. Got it? समझ में आ गई बात बच्ची? So now, and we know that from the Boyle's law, we can say that P is inversely proportional to V, isn't it? So instead of this, we can write this also. W is equal to minus 2.303 nRT log, and V final is upside, so here it will be P initial upon P final, because it is reciprocal to. Yes, done with that, inversely proportional. So this we got work done. Am I clear with this? Is it clear? That derivation is clear? Got it? Okay. So this thing, and now I just want to how this piston will be in the equilibrium. कैसे equilibrium में होगा, कैसे system equilibrium में होगा? Let me explain. So see, if we are taking out the small mass from this, that means the pressure is going to be increased and hence there will be expansion. Got it? And that there is a point that wherever the expansion, it results in cooling. Expansion results in cooling. Got it? So there will be expansion, that means temperature is going to fall. Yes, and if system temperature is down than the surrounding, so what will happen? The heat will transfer from the surrounding to the system, because it is isothermally conducting, so it will conduct to maintain the equilibrium, and heat तब तक flow होता रहेगा जब तक ये दोनों system and surrounding जो है वो equilibrium में नहीं आ जाते, again the thermal equilibrium में नहीं आ जाते. Got it? Small amount of mass like removed, due to which the P gas becomes greater than the P external, and hence there will be expansion, and expansion results in cooling. So cooling, that means temperature fall down, and to maintain that, since the wall is isothermal, so heat will transfer from the surrounding to the system to maintain it in the thermal equilibrium. Got it? Done with that? So by this way it will be in the equilibrium. Okay, so now we will know the work done. There is an irreversible isothermal also, that we will know. Okay, now we will do the work done in the irreversible isothermal expansion. Okay, so again expansion we will mention, and as I told you expansion, as I told you in the starting only, that whenever we see that irreversible, whether it is isothermal or adiabatic, don't worry about that. We will simply assume this work done is equal to P minus P external dV. Clear? Okay, so there is a two case. First case is in vacuum. Yes, so we vacuum, there is a P external 0, so work done will be 0. Clear? Any doubt in this? Now, if second thing, if P external is so less than P gas, मतलब बहुत बहुत ज़्यादा कम है जिसकी वजह से गैस क्या हो रही है, एक्सपैंड हो रही है. Got it? Then there will be simple formula. We will find change in volume will be there. So that is minus P external and delta V we will use. ठीक है, because pressure external pressure पे constant है, that is external pressure हमेशा use करते हैं. That is not going to change since P gas is smaller, P gas is greater than the P external, so that's why the gas is undergoing expansion, and if it expands, there will be volume change, and that is, and it will, since it is expansion, so what we will do, it will always be negative. Got it, dear? Okay, so now few questions are there in that that question work done in, can be asked in form of graph also. So some graph will be given to you, and then they can ask that what is the work done in this case. So how to do, let's see. So there are some questions. So out of that, one question is here: find out the work done in the following expansion, and the graph is given. So see, in that cyclic process, or in that where I have explained, that is always the work done is always the PV graph, under the PV graph. Got it? So this thing we have to follow. खैर इसकी ज़रूरत यहाँ पे तो नहीं भी पड़ेगी, and you can, if you want, so you can use that also. This is, suppose that this is the area under PV graph, isn't it? So we can find that work done is equal to area under PV graph. Yeah, because it is graph question, so you can use this formula also. Otherwise, you that P delta V, that also you can use. There is no problem. Area under PV graph, okay, and that will be P external, because see that pressure is changing, isn't it? 0 to 3. So we cannot use this formula P external because the pressure is changing. Is it clear? So sorry, this formula won't be used. We will use this wherever the pressure change is there. We will use this area under PV graph, and we can see that it is a triangle, isn't it? So we can write half into BH, that formula. That means half base is change in volume is 3, 0 to 0 minus 3, that means 3. Can we write? And the height is, the pressure is 0 to 3, again the 3. So we can see 9 upon 2, that means 4.5. And what will be the unit for this? It is in ATM and it is in liter. So this will be ATM liter. And if we want to convert it into joule, what I said, we have to multiply by 101.3, isn't it? Because 1 ATM liter is equal to 101.3. So just multiply by 4.3 into 101.3, and this will give you the value in the joule. The work done will be in the joule. Any problem in this? Okay. So here is the next question, and the next question is like this. This is the cyclic process. The first it changes to A to B, and then B to C, and then C to A. This is the process like this. Okay. You have to find the work done. So simply you can say that it is 0 because it is cyclic process. Will it this answer will be 0? No. How? Let's prove. We will prove. And that's why I have in the starting only I have told you. You can see that in the cyclic process work done is not equal to 0. If you will do that Fs work done, so there will be, yes, it will be 0 because displacement is 0. But in physics, we don't have to use this Fs. In the physics, it is Fs, but we don't have to use Fs work done. What we have to use? We have to use PV work done. Okay, so let's find this PV. Now, if I find work AB from there to there, so that means this is, we can we'll do one by one. Okay, so let it be, and this is what we will do. In this case, if we consider, this is, isn't it, the work AB, A change into B. So what we are getting, this is the trapezium. So we can say that area of work AB will be equal to area of trapezium, and that trapezium is ABCD, isn't it? Okay, so the formula, you know that half into sum of the sides into the height, into the base. So sum of the side is, this is 2, isn't it? Plus this will be 10. and into the base is 5. So it will be 12, 6 5 ja 30 atm liter. What will be the sign in this? Okay, so that I will tell you. If we want to do this, I will tell you how to do, find afterwards I will find. Okay, let it be. Now this is WBC. If we find, this is, see, in this case BCC, what is that? Volume is not going to change. So work BC will be, we use P external and BC, okay, or delta V, sorry, it will be delta V, yes, delta V, I will mention it afterwards. So here delta V is 0, so that's why WBC will be what? 0, isn't it? Now the CA, the pressure is going to be constant 2, yes, so we can use this WCA, P external into delta V. So P external is here 2 and delta V is 5 minus 1. 5 minus 1 yani ki 4. This is 4 to the 8. 8 what? ATM per liter. ATM liter, isn't it? Now tell me, in this case, if I have to go from this side there to there, so check, the volume is 1, isn't it? And the volume is here 5. That means it is going to be expand. And if there is expansion, the work done is always negative. Got it? As expansion. Yes, dear? In this case, so there is no problem. In this case, the volume is right now, initial is C point, na? So it, at this time 5. And then when we move, the volume is going to be decreased. Yani ki there is a compression. And if there is like a contraction, that means it is positive as contraction. So what will be the total work done? The total work done will be, we can find WAB plus WBC plus WCA, and we are getting minus 30, yes, and plus 8, so this is minus 22 atm liter, isn't it? Got it? Okay, one more thing. Here is the next question given. The next question is this, okay, and this means A to B, the work, and then B to C, and then C to A. This is a cyclic process, okay. So first it is going to A to B, and then B to C, and then it returns back to C to A, okay. So this is a cyclic process. So can we say that the work done in this whole process is 0? No, we cannot say. And how? We will prove it at last, okay. So first let me do with this work AB. As I told you that, see, if during this AB we can see that the pressure is not going to remain constant, isn't it? That means the P external into delta V, want this formula we will not use. So what we will use? We will simply use that A. So for work done AB, see, we can see that the pressure is not constant. So what will happen? This is complete area under PV. So we can say that WAB is equal to area under PV graph, isn't it? So area under PV graph, if we check, what we are getting? We are getting a trapezium, yes. So the formula of trapezium is equal to half into sum of the sides. That means sum of the side is, here it is 2 and here it is 6. 2 plus 6 into the distance between the two parallel lines. The distance between parallel lines is 5 minus 1, 4, isn't it? I am using direct formula. So this is 12. 12 divided by 2, it will be 6. 6 4 ja what? Is it okay? This is 2 plus 6, 8, sorry, it is 8. 8 divided by 2, it will be 4. 4 4 just 16. So this is 16 atm liter. Now I just want to ask whether it will be positive or negative. So you can see that initially the volume is here 1 and the final volume is at this point. That means volume is going to be increased, and if volume increases, so obviously it is a case of expansion, and if it is an expansion, the work done is always negative, isn't it? So we will do like that. Clear? Now the next question. Now the second thing is WBC. So BC, we can see B to C. There is again no constant pressure. So area under we can find, but this is a line. So line के अंदर क्या कौन सा area हो सकता है? There can nothing. So we will simply use that what volume वाला check करेंगे. So volume is here 5 initial. At this is the initial point. Volume is 5. Final also the volume is 5. So delta V is equal to 0. So work done simply what we will say 0. Clear? Now the third one is words WCA. So CA is here to here, and we can see that the pressure is going to be constant, isn't it? So we can use this formula minus P, we'll use afterwards minus wala part like this. So P external is 2 over here, and delta V is 5 minus 1, yani ki 4. So this is 8. And what it will be? It will be positive or negative? Tell me fast, because here it is, earlier it was 5 and now it is 1. So there is a contraction. So contraction, that means work done is positive, isn't it? Clear? So we can write this. Now this is atm per liter. And if I will ask that what will be the total pressure? So total work done. We can see that total work done is equal to, we can say WAB plus WBC plus WCA. Another way also I will explain how to solve it. So WAB, we can see what it is. This is minus 16, then it is 0, and then it is plus 8. So it is minus 8 atm per liter, isn't it? Other way, alternative way, if we have to find that work done in this cycle, so this is the area under the PV graph for this cycle. Yes, this is the area, isn't it? So this is a triangle, so we can say that, or area of triangle ABC, and that is half into BH, isn't it? So what is that? Half. B is basis here, 5 minus 1 4, and H is this 6 minus 2, it is 4. So what it will be? We can say 16 divided by 2 atm per liter. And in this way you will not be fine to that sign. So for sign I am going to give you a simple formula. If work done is in clockwise, work done is clockwise, it will be negative, W will be negative. And if anti-clockwise, the work done will be positive. So this simple trick you can use, and you can use the direct formula also. So here see, this is work done, it is going like this, as a work done is in clockwise, so you can use this negative sign over here, and the answer is like this. Any doubt in this? I hope it is clear. Okay, so now the next thing, next question and the last question for today, that is this. In this, it is a rectangular cyclic process like this, and we have to find the work done AB, BC, CD and all that. Okay, so let's do with this AB. Again, it is a line, the volume is not going to change. Yes, so delta V is equal to 0, so work done is equal to 0, we can say, isn't it? Now for WBC, if we go to from this to this, the pressure is going to be constant. Pressure is constant. So we can use this P external into delta V, and P external is 6, delta V is 4, minus, final is this 4 minus 1, 3, isn't it? So this will be 18 atm liter. What will be the sign? Just check. The volume is going to increase. The volume is 1 to 4, it is going. So volume is increasing, that means again it is like expansion. Yes, so minus. Now CD, again it is a line, and the line volume is not going to change here also, so we can say 0, that means WCD is also 0. Yes, now one question is left here. D should be DA. Let me find for first this, and then we will do this total work done. Okay, so DA is this to this. Yes, so again the pressure is constant, so we can use that WDA is equal to pressure external into delta V. So pressure external is 2 and delta V is initial, it is 4 and final it is 1. So this is 6 atm liter. What will be the sign? Just check. Sorry, पढ़ नहीं होगा. atm liter. What will be the sign? It is going to be contract. The volume is earlier 4 and now it is 1. Contraction. So work done will be positive. And if we'll check that the total work done is equal to minus 18 plus 16, that means total work done will be what? Minus 12 atm liter. Now just do it in that area form. So work done is equal to, we can say that total work done is equal to area, or let me explain, area under rectangular A, B, C, D. What is the formula? L into B. Yes. So L into B, we will use L क्या है यहाँ पे check करो. This is 2 and this is 6, so it is 4. And what is that width? This is 8. This one is the width, यानी कि it is 4 and this is 1, it is 3, so it will be 12 atm liter. What will be the sign? Direction, since it is going clockwise, so it is clockwise movement, so that's why it is negative. We can check. We are getting the same values, isn't it? So here we can see that here by this way we can prove that the work done in the cyclic process is not equal to 0. Although the energy will be 0, but work done won't be 0. Okay. So okay class, for today that's it, and next day we will start the next thing, adiabatic process and all. Till then, thank you class.